Today I'm going to start a new video series. I don't know. I will cover this topic visual acuity in six, seven, or maybe eight videos. So this is part one. I'm just going to start, and I'm going to start slowly, not being in rush to cover the visual acuity because I think I need 2 to 3 days to cover all the visual acuity components. So let's move. So today I'm going to cover visual acuity, especially angular expression and how angular expression relevant for visual acuity. Actually, I think visual acuity is all about angles, and there are a lot of things how angles plays a role in case of visual acuity. Okay, so I'm just talking about visual acuity. I think I have 10 or 11 slides, so I have just covered today totally about angular expression. Okay, visual acuity, first of all, visual acuity is not a vision, it's just a visual acuity. Okay, in case of vision, in rough, vision is in essence the ability of our brain to recognize the object from that forms in the retina. Recognizing object, so sometimes people call vision as a integrated sense of form vision, color vision, contrast, light perception, and many more things, isn't it? A visual field, sometimes people call it vision is visual field too. So there are a lot of things that comes into the visual function, and one of the visual function is visual acuity. So that's why visual acuity is not equal to vision, period. Okay, so second thing, visual acuity is a numerical variable that characterize the ability of visual system to recognize optotypes. Sometimes we use as a recognize optotype. Sometimes we call it a resolving capacity of eye, how much we can resolve. Okay, but visual acuity is not vision. That's why visual acuity is limited. Visual acuity, particularly in case if I'm talking in a sense of visual perception, then visual acuity is definitely a form perception, not a color perception, not contrast perception. Obviously, yes, contrast plays a big role, but not that. But visual acuity is a form perception, isn't it? Okay, so let's move. So, angular expression, it's very important when you are talking about vision. We must understand the angular expression because what do you mean by 6 by 6? It means by definitely minimum angle of resolution is 1. And what do you mean by a minimum angle of resolution? Because it shows us the difference between two resolving things, whatever it is. It is in our nodal point, it's 1 minute of arc, oh, isn't it? So that's why what is actually angular expression? See, angular expression means always length divided by length, isn't it? But it whenever it called theta, it's called arc divided by radius, isn't it? So arc in something centimeter, radius in something centimeter. That's why theta doesn't have any dimension. That's why angle is dimensionless, but not a unitless. Angle is definitely, it has unit, but it has no dimensions. Units like degree and radiant, and SI unit is definitely radiant. Okay, so you must, I have already told you what is, you must know how to convert degree from radiant. We know that, right? 2 pi radian means 360 degree. 1 radians means 360 divided by 2 pi, and convert it. Okay, 1 radiant means, which is around 57.3. So you should be fast enough to understand these things. Okay, so you have to be fast enough. 360 degree means what? How many arc minute? And into 60 minutes, how many arc seconds? So 1 degree is one portion out of 360 portion in one circle, and 1 minute means if you divide 1 degree into the 60 portion, then one portion is called 1 minute. And if you divide 1 minute into 60 portion, then this you call 1 second, or 1 arc second, one uh, second arc. Okay, minute and second and degree, you must know this, all these things, because in visual acuity you it these terms come back and back and back. Okay, so a small angle approximation, what is a small angle approximation? We have already discussed it in case of our, what do you call that, aberration in paraxial approximation, which is similar as a small angle approximation. Sine theta equals to theta equals to tan theta when theta is radian. Just remember one thing, if it is very small angle and this is something height, this in uh, length, okay, breadth, or this is length. Then in case of sine theta, what is this sine theta means? This h divided by length, isn't it? What is it tan theta means? H divided by b. So whenever theta is radiant, h divided by l and h divided by b is equal. So we must know theta is in radian, but also we must know theta is very small. Theta is small. If you consider theta is 30, sorry, theta is, for example, 2 pi, or theta is 1 pi, in that condition, uh, a small angle approximation doesn't work. So you must know what is a small angle approximation. For a small angle approximation, whenever there is angle is small, at that condition, so angle must be in radian. Okay, angle must be in radian. At that condition, sine theta and tan theta is equal to theta, and theta in obviously radian. You must understand this concept, and it will make your life very easier whenever we are going to calculate anything in visual acuity. Okay, so what is viewing angle or what is apparent angle? So let me define first. So viewing angle or apparent angle can be used to express the angle formed at nodal point. Okay, fine. Formed at nodal point. Doesn't matter nodal point formed at anterior nodal point or the posterior nodal point, secondary nodal point, primary nodal point, because in nodal point, what is the feature of nodal point? Remember, the feature of the nodal point is angular constancy. It doesn't matter angle made at the primary nodal point is 20 degree, then same angle going to be there in secondary nodal point. So formed at the nodal point of an eye between the two lines of sight drawn from the edge of the target, or between the two target or features that target. Suppose this is the license plate, and one edge of the license plate, here is the line of sight, another edge of the license plate, here is the line of sight, and the angle between that line of sight is basically theta is equal to s divided by d. This is d, this is s. If theta is smaller, if theta in radiant, isn't it? That's what we are talking about. So that's viewing angle. Viewing angle made by a large license plate. So that's the viewing angle. Okay, viewing, the most important thing you have to understand about viewing angle is it formed at a nodal point. Okay. So, in conclusion, about visual acuity is not vision. It's just a visual acuity. It's a form perception. So it's not a color perception. It's not a contrast perception. It's not a light perception. It's not a visual field. It's a visual acuity, which is a form perception. And many more visual acuity is defined as an angle. So you think visual acuity is defined by 6 by 6, isn't it? So you think visual acuity divided by 6 by 6 or 20 by 20. So if you resolve it in more, then you will get angle eventually. So there are a lot of things. If you don't have angle, then sometimes we describe visual acuity as a 30 degrees per 30 cycles per degree, isn't it? What's this? 30 cycles per degree. So these are other units that you use for visual acuity, but eventually at the base of the visual acuity there is definitely angle. So you must understand how angle works. Okay, it's centrally important how angle works. Visual acuity is not vision, and angle, you must understand sine theta is equal to tan theta is equal to theta when theta is radiant and when theta is small enough. So in this condition, this is called small angle approximation, and we have already discussed about it in case of paraxial approximation. Okay, so this is the very basics of visual acuity. Don't skip this video and just go to other videos. This is very basics, and we are going to we are coming back again and again in video 1 part 1. Okay, for this topic, this is it. Today I have taken only one reference from my favorite book and from my favorite author, Professor Dr. Joseph Simiris. Okay, bis dann. Tschüss. Bye.